glacial features in Ohio and unglaciated features in Ohio in particular. It's become a real important facet of what makes up Ohio and the opportunities and the different characteristics of the cities that have made up Ohio and what people do for a living in Ohio. So it's really kind of important to recognize that. I also on this slide have a diagram that talks about the Great Lakes. So I've got two things that I need to say on this slide. So what we had was the Laurentide Glacier was formed in Canada, and with that, with the erosion zone was everything that was north of the Great Lakes. So over tens of thousands of years, we're scouring, we're plucking, we're pulling, we're pushing material out of Canada, and we're depositing it in Ohio. So everything on this margin here that's greens and oranges and blues is material that was deposited that originated in Canada. All right, everything in this, I don't know what color this is, a weird salmon color, I guess, is the part of the Allegheny Plateau. The glaciers terminated at this margin, and for a couple of reasons. It was the end of the glaciation, so there wasn't enough energy to continue to keep that glacier moving. But the Allegheny Plateau is pretty substantial, and it was a barrier at the very end of the glacial advancement. So we move into high upland areas through here. We would call this today part of Appalachia. All right, so with that, these areas here afforded Ohio to be an industrial might uh, for a large part of America's history, primarily sort of this northern portion. Um, the greens are really a lot of debris. We're seeing end moraines, terminal moraines, lateral moraines here that are being deposited. The oranges are part of lobes that were left behind. We're getting materials down here towards the south, which are fine grained materials out of outwash plains. I've got a fantastic outwash plain in here. So we can see just by the texture and the density of these maps how flat this area was. And the blue is lacustrine material, which is really, really fine material. So we know this up in here is all agriculture, right? This is really a flat part of Ohio because we've got lake deposits occurring here. We've got outwash material here, less flat, but flatter than this part of Ohio. So we've got agriculture in here too. And this agriculture really has is afforded by a finer grain material. You can kind of see a dendritic pattern established here where there was a lobe and it drained into a proto river valley. So this is kind of what we've got going on here in Ohio on a small scale, echoed across the rest of the Laurentide feature into other parts of the United States and parts of Canada. The Great Lakes are fantastic. They are a remnant of a glacial period. They are all glacial ice. This is the meltwater from the glaciers. I want to underpin that even though there is water being added to the Great Lakes over time, it's negligible amount compared to what's in these lakes now. This is, consider it almost like fossil water. All right, so the Great Lakes were one large lake early on. The lakes were Chicago and Whistler and all one big feature. So we're seeing these blue lobes, which were the margin of the ice. So this is melting, leaving this structure behind. As the ice continues to melt, we're melting faster, depositing more material. and emptying out, we start to see what used to be a depression because of the glacial lobe. This is going to fill up with water. All right, we fill that up with water and we get a little bit of a last push in the glaciers here. About 11,000 years ago, depressing that area a little bit further, really creating these deep lakes, which are going to become Lake Superior ultimately, and leaving these features behind, and eventually leaving behind the Great Lakes as we know them today. Last thing that I need to say to you is, remember I had mentioned looking at the margin between the Cordilleran Glacier, which is really alpine glaciers, and then the Laurentide ice sheet. This left us an ice-free corridor at that margin that was separated as the glacier started to melt. And it's considered an ice-free corridor. And it used to be archaeologically that we thought that over the Bering Strait in Beringia, that the Native Americans, First Nations people came and accessed this corridor for habitation into the United States. So I've got Folsom and Clovis peoples that we have their spear points and arrowheads left behind down here in the American Southwest. I've also got recognition that we've got habitation along this frontier of this erratic terrain that I talked about earlier. But we now know that this is what this landscape would have looked like. Not a lot of vegetation, and you were traveling by foot, which means at a maximum rate of movement of 8 miles a day, we're going to take a lot of time to move through this environment, which hasn't generated any evidence of human occupation. The earliest occupation happens here in the south. We should have seen archaeological evidence here that's younger, or pardon me, older, happened sooner than here, and that hasn't happened. So we now know that this landscape, if there's no vegetation, there's not going to be any animal life to forage on that vegetation, which means humans wouldn't have followed a prey through the ice-free corridor. What likely happened was the area of access was probably out here as the Pacific retreated and that water was moved to an ice mass, that it was along the earlier Pacific Ocean volume that they accessed fish proteins and moved out here. So the archaeological evidence that we were looking for to offer evidence for why we have these Clovis points and these Folsom points out here in the American South is we're finding now in these aquatic environments. So pretty interesting stuff. All right, that terminates the glacial geomorphology.